This app says the user is an administrator. The token has an email, a role, and an expiration date. The dashboard is green. The login flow looks finished. There is only one problem. The server decoded the token and trusted the JSON. It never proved who signed it. That is not a rare vocabulary mistake. It is a broken trust boundary. In the next 12 minutes, we will run 7 local tests that an AI-built app should pass before it trusts a JWT. No public target, no real account, and no magic security scanner. Just an invented app, fake users, fake keys, and behavior you can prove. JWT stands for JSON Web Token. A common signed JWT has 3 encoded segments: a header, a payload, and a signature. The payload contains claims, statements such as subject, issuer, audience, expiration, or a custom role. Those claims are usually readable by anyone who has the token. Encoding is not encryption. The signature lets a recipient detect whether the protected content was changed, but only if the recipient performs verification with a trusted key and an expected algorithm. And even a valid signature answers only one part of the question. Your API must still ask, who issued this token? Was it meant for this API? Is it active now? What kind of token is it? And may this identity perform this action on this resource? We will turn each question into a test. Check 1 is the simplest. Decoding is not verification. A decoder takes the token segments and returns the JSON claims. That is useful for display or debugging, but the returned claims are untrusted until verification succeeds. In our fixture, the server uses a decode function, reads role admin, and continues. The test changes the payload in a locally generated token without producing a valid signature. The route still returns 200. Red test. The fix is not to compare one field manually. The server must use a maintained JWT verification library, provide trusted verification material, and reject the complete token when cryptographic verification fails. After the change, decoding can still happen inside the library, but trust begins only after verification returns a valid result. The modified token now receives an authentication failure before business logic runs. Your first proof is behavioral. A token with changed protected content is rejected. Check 2 is algorithm policy. The JWT header can name an algorithm. That header arrives with the token, so your application must not treat it as permission to choose any verification mode the sender requests. The IETF's JWT best current practice says libraries must let the caller specify supported algorithms, and the verifier must not accept others. In plain language, your application decides what it accepts. Our fixture expects one configured algorithm. The test generates another locally signed token using a different algorithm. The signature can be mathematically valid for that other setup, but this API must still reject it because it falls outside policy. Avoid copying an algorithm list from a random tutorial. Choose the library and provider configuration that matches your architecture, keep dependencies current, and review changes during key rotation. The reusable rule is the Allowlist, not one universal algorithm string. Check 3 is key trust. A valid signature proves nothing if you accept a key from an untrusted place. The verifier needs a trusted key configuration or a trusted issuer metadata path. If keys rotate, the server may use a key ID to select among known public keys, but that identifier is still untrusted input. It must not become an arbitrary file path, database query, or URL fetch. Our local fixture has one active fake key, one retired fake key, and one unknown key. 3 tests follow. The active key succeeds. The retired key follows the exact overlap rule we configured for rotation. The unknown key fails closed. If key lookup fails or returns an unexpected key type, the request fails. It does not fall back to decode-only behavior. This is also why the library handles JWT is not enough evidence. You need to show where trusted keys come from, how rotation works, what is cached, and what the application does when lookup fails. Check 4 catches a subtler mistake. Accepting a legitimate token in the wrong place. The issuer claim identifies the authority that created the token. The audience claim identifies the intended recipient or recipients. The IETF guidance explicitly recommends validating them. In our fixture, the expected issuer is an invented local authority, and the expected audience is Project API. We create one correctly signed token for billing API. Everything about the signature is valid. The token is current. The user exists. But it was not issued for this API. The test must reject it. Then we create a token with the correct audience but the wrong issuer. Reject again. This matters in systems with multiple APIs, multiple environments, or more than one identity provider. It came from our login system is not a precise trust rule. The verifier should know the expected issuer and audience for this route. Check 5 is time. An expiration claim says when the token must stop being accepted. A not before claim can say when acceptance may begin. The verifier may need a small explicit clock tolerance because distributed systems do not share a perfect clock, but an unlimited tolerance makes the claim meaningless. Our tests use a frozen fake clock. That makes the behavior deterministic. One token expired 1 second before the allowed boundary. Reject. One token is not active yet. Reject. One token is current. Accept. Then move the fake clock forward and prove that the same token expires. Do not fix time tests with a real sleep. Freeze the clock so the result is fast and repeatable. And remember the scope. Expiration limits token lifetime. It does not automatically log out every device instantly, revoke a stolen refresh token, or remove a user who lost permission. Those lifecycle decisions need their own design. Check 6 is token purpose. JWT is a format used by different protocols and token types. An ID token tells a client about an authentication event. An access token is presented to a resource server according to the provider and API design. A refresh token is used to obtain new tokens and may not be a JWT at all. These objects are not interchangeable just because they look similar when decoded. Our fixture creates 2 signed tokens from the same fake issuer. One is marked and claimed as the access token this API expects. The other represents an ID token intended for a client application. Both signatures are valid. Only one may enter the API. The test checks the expected audience, token type or purpose signal defined by our fixture, and mutually exclusive validation rules. The wrong token is rejected. In a real stack, follow the provider's official resource server validation guidance. Do not invent a custom claim convention from this animation. Check 7 is the boundary that login tutorials most often skip. Authentication is not authorization. At this point, user B has a completely valid access token. Correct signature. Correct issuer. Correct audience. Current time. Correct purpose. User B still must not read user A's private project. The root needs a server-side policy that considers the authenticated actor, the requested action, and the target resource. OWASP recommends deny by default and validating permission on every request. Our 2-user test creates a record owned by user A. Then, user B attempts 4 actions: read, update, delete, and list. Every path must either exclude the record or return a safe denial. Hiding the edit button does not count. A client-side filter does not count. Reading a role from the token does not prove ownership. Also inspect failure output. The denial must not leak the private record through an error body, a log shown to the user, or a difference that reveals sensitive metadata unnecessarily. Then run the same matrix for organization membership or roles if your app uses them. Role-based access may answer whether someone is an editor. It may not answer whether that editor belongs to this tenant or owns this object. The proof is a matrix: actor, resource, action, rule, enforcement location, and automated test. The 7 checks protect a request boundary, but a real session has a life cycle. Ask what happens after logout. If access tokens remain valid until expiration, say that explicitly and choose a bounded lifetime appropriate to the risk. Ask how refresh tokens are stored, rotated, reused, and revoked according to your provider and threat model. Ask what happens when a user is disabled or removed from an organization. Ask whether authorization decisions rely on stale claims for too long. There is no single answer for every architecture. A short-lived access token reduces one risk, but can increase refresh traffic and complexity. Server-side session state improves immediate revocation but changes scalability and availability trade-offs. Browser storage choices depend on the application and attack model. What matters here is that the design is explicit, documented, and tested. JWT is stateless is not a logout strategy. Add controlled tests for disabled users, permission changes, refresh replay, and session termination based on the provider behavior you actually use. Here is the audit prompt I would give an AI coding agent before asking for edits. Do not change code yet. Map every route that accepts an access token. For each route, identify the verification library, allowed algorithms, trusted key source, expected issuer, expected audience, time claim handling, token purpose rule, authorization policy, and automated negative tests. Provide file and line references. Mark anything you cannot prove as unknown. Do not infer protection from middleware names or hidden UI, then inspect the evidence yourself. Middleware can be registered on some routes and missing from another. A helper named verify token can still call decode. A test can assert a 200 response without testing the denial path. An AI summary is a map to inspect, not the proof. Your final table should have 7 rows from this video and 3 states: pass, fail, or unknown. Unknown on a public route that handles money, identity, health, or private multi-user data is a launch blocker until you resolve it with qualified review. A JWT is not a permission slip because it contains convincing JSON. Trust starts with verification, becomes specific through issuer, audience, time, and purpose checks, and ends with authorization on the requested resource. Use these 7 tests in your local app. Keep the tokens, keys, users, and targets invented until the test boundary is safe. The pre-ship checklist linked below includes the same pass, fail, and unknown discipline for the rest of an AI-built app. If you want the next episode for a specific stack, comment with the provider and framework, but the episode will verify the current official flow before copying any code. Do not ship reassurance. Ship the evidence.